Okay, simplify radicals. We discussed that in order to add radicals, we already kind of experienced this, but what's underneath the radical has to be identical. What I mean by that, if we have the square root of 5 minus the square root of 3, many of you think that that equals the square root of 2, and that is actually incorrect. To show you, I can take, in my calculator, I can do the square root of 5, I get 2.236, about, and I'm going to subtract the square root of 3 from it. So the square root of 5 minus the square root of 3 gives me like 0.504017. Okay, so we're saying that since this equals the square root of 2, when I take the square root of 2, it is also going to equal 0.504, and it doesn't. It equals 1.41. So you can't just subtract radicals like you do numbers. You can only add or subtract them when whatever is underneath the radical is identical. So here, these are both cube roots, so that's a good sign, and it's the cube root of x. So this actually simplifies to 2 and then cube root of x. Okay, here, notice what's under the radical is the same. So it's going to be 2 plus 3, which is 5, square root of 7. Here, 4th root of 5, 4th root of 5, okay? So 7 minus 2 is 5, so this is going to be 5, 4th root of 5. Here, this is 4xy plus, 4 radical xy plus 5 radical xy. What's underneath the radical, they're both square roots and they're the exact same, so that's going to go to 9 square root of xy. So really, in a sense, it's almost like the radical, it's just like x squared even. If I had 5x squared minus 3x squared, it doesn't equal 2. The x squareds don't cancel. It equals 2x squared. Okay, so I have 3 radical x's, and I'm taking away 3 radical x's. So how many radical x's do I have left? 2. Okay? Now, unfortunately, these problems aren't going to be as easy as that first one. We're not going to be given the radical to where we can simplify that easily. We're going to have to simplify the radical. So this is, again, piggybacking off of our last lesson. We look, if I want to add this, remember what's underneath the radical has to be the same. This is the square root of 2, that's the square root of 3. Can either of these be broken down? Can I break the square root of 2 down? No. Can I break the square root of 3 down? No. So that's it. You can't. This is already simplified. It's done. There's nothing else we can do. Now this one, we're going to have to break down. Again, it's all square roots, so it makes it a little bit easier for us. I know my square numbers. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, yada yada, 169, we'll keep going. So I'm going to try to find the square number, because clearly I'm going to have to break down all 3 of those, because I have to get them all to where I can add them. So the square number I know that goes into 72 is 36. So this can be rewritten as, let me move all these, can't. Alright, so this is going to be rewritten as the square root of 36 times 2. We've already practiced that. 32, well that's 16 and 2. Okay, so this is going to be rewritten as the square root of 16 times 2. And 18 is 9 and 2, so that's going to be rewritten as the square root of 9 times 2. And each of those then can get broken down again, just like we did last lesson. The square root of 36 is 6. And then the square root of 2 can't get broken down. So it's 6 square root of 2 plus square root of 16 is 4. Square root of 2 can't get broken down, so it's going to stay square root of 2. Plus square root of 9 is 3. Square root of 2 can't get broken down. Now, if you notice, everything that's under the radical is the same, unlike there. Not the same. So these I can add. Square root of 2 plus square root of 2 plus, 6 square root of 2 plus 4 more square root of 2's plus 3 more square root of 2's will give me 13 square root of 2. Now this is actually an easier example. Then we'll have something a little bit harder like this. Now we already know that 18 can get broken down into 9 times 2. So what do we do when there's a 6 out in front of it? Well, this is basically just going to serve as 6 times square root of 18 simplified to 3 radical 2. So it's basically 6 times, 3 square root of 2. So when we do that, we just do the 6 times, like last lesson, we multiply, we can only multiply the coefficients, now it's underneath the radical. So it's 6 times 3, which is 18 square root of 2. So that's how that breaks down. So this is 4. And we haven't done the square root of 8 yet, but the square root of 8 can get broken down into 4 times 2. And the square root of 4 is 2, so this is basically 2 times the square root of 2. And then just like this, we can only multiply the 4 and the 2 that are outside the radicals together, so giving us 8 square root of 2. And then square root of 72 we broke down here, and it goes to 6 radical 2, so this is basically 3 times 6 radical 2. 3 times 6 is 18. Square root of 2. And then all my radicals are the same, so it's just a matter of adding what's outside and subtracting. So 18 plus 8 is 26. 26 minus 18 is 8. So here we have 8 radical 2 as our answer. Okay, this one. So this is just identical, another example of this one. Just different problems. Square root of 50. Hopefully at this point we're a little bit stronger breaking down square roots. So the square root of 50 gets broken down to the square root of 25 times 2. And the square root of 25 is 5. So this is actually 5 radical 2. Plus, this is going to be 3. The square root of 32 we broke down here, thankfully, we've already done it, and that's 4 square root of 2. And then, that, I'm going to erase it, you don't have to, you just write it below it or something, next to it, however you work through your notes. Multiply, just so we get it up there, 3 times 4 is 2, so it's going to be plus 12 square root of 2. And then minus square root of 18 is broken down to 3 radical 2, so it's going to be 5 times 3 radical 2, just like we did before. We can only multiply the 5 and 3 together, so that's going to be 15 square root of 2. And then find everything. 5 plus 12 is 17, so we have 17 square root of 2 minus 15 square root of 2 is going to be 2 square root of 2, and you're done with that. And by all means, you can always check to make sure you do it correctly using your calculator. I would, and you're probably not going to be able to see this because it's probably going to be off, but with my calculator, I would just start at the beginning, like do square root of 50. Square root of 50 plus, 3 times the square root of 32, and then minus 5 times the square root of 18. And I get that 2.828. And then I'm also going to do 2 and then square root of 2. And that equals 2.828427125, which is exactly what the original expression equaled. So that way I know I broke it down correctly and I did it right. This next one, now, it won't always break down to the square root of 2. It just so happened with these problems I chose that it is. So this one, 32x plus square root of 98x. Same thing, we're going to have to break that down like we have all of the others. So here, the square, I know 32 gets broken into 4 square root of 2. Okay, well, that, the only difference is this is 32x. We can't take the square root of x, it just stays as the square root of x. So really this, I'm going to put this over here, is going to be 5 times 4 square root of 2x, which simplifies to 20 square root of 2x. Okay, and then 98x, we haven't broken 98 down yet, 49 works for that. So we'll have this is the square root of 49 times 2 times x. Okay, the square root of 49 is 7, so we're going to have plus 4 times 7, and then square root of 2x. 4 times 7 is 28, so we have 28 square root of 2x. 28 plus 20 is 48 square root of 2x. And again, we can't take the square root of 2, and we can't take the square root of x, that's why they're staying underneath the radical. So there's that answer there. And then here, to break down this, we can't take the square root of 216. At least I don't think we, yep, no, it doesn't work, so we're gonna break 216 down. And 216 divided by 2 is 108, so I'm going to test everything below that, so I'm going to try 81. So 162 divided by 81, 216 divided by 81 doesn't work. 216 divided by 64 doesn't work. 216 divided by 49 doesn't work. 216 divided by 36 does work. So this is 4, and then the square root of 36 times 6. And at this point, we should know that the square root of y squared is y. So that's actually 4y out front. And then this is going to go to 4y times the 6 square root of 6. Why? Because the square root of 36 is 6, and we can't do the square root of 6. So this is actually 24y square root of 6. Okay, plus, okay, well 54. I'll give you a hint. Since my number under the radical here is 6, I know that the number under the radical here needs to be 6 as well. So in my calculator, I'm just going to do 54 divided by 6, which is 9. So 9 must be the perfect square that goes into this. So I bring the 3 down, and then it's going to be the square root of 9 times 6. Square root of y squared is y. So it's going to be 3y times 3 square root of 6, which is going to be 9y square root of 6. Combined in like terms, 24 plus 9y is 33. Right? For some reason that doesn't seem right. It's 33y square root of 6. So that's a little bit of how you can add radicals. And there's more video coming up, but I thought it'd be a good time for you to maybe take a break, process everything you've learned, walk away from the computer for a minute or two, and then come back to it.